So we spent a lot of time graphing, but what about reverse, right? So can I find a function that fits information that's given? In the past, I've called that curve fitting, and I'm going to continue to call it curve fitting. So last week what we did is we curve fit polynomials. I gave you zeros, and you were able to build a polynomial based off of those zeros. So same thing here. Can I give you information, and then from that information, you build a rational function that fits the data given? And of course, you can be able to do it, because I wouldn't ask you to do it if we couldn't. So here's how this is going to look. Okay. So for the first one, we got to find a rational function that has a vertical asymptote at x equals to 1. So what that tells me, since the vertical asymptote's there, I know that x minus 1 has to be a factor down on the bottom, because x equals 1 to 0, right, to be the vertical asymptote. The horizontal asymptote is y equals to 0. So what this basically tells me is that my degree in the numerator, right, is less than the degree in the denominator. Well, I already have a degree 1, so really all I need is a number up above, and just pick your favorite number. So how about I pick 2? So I think the function that fits this information is 2 over x minus 1. Are there more? Yes. Right? You can play around with your variable upstairs. You can even introduce another factor if you want, because I'm just saying it has to have a vertical asymptote at x equals 1. Maybe you want to throw a hole in there. Maybe you want to do something else. But if I just want to bare bones fit what I have, I need a 0 of 1 down in the denominator, and my degree has to be less than the denominator. I think I've got everything I need right there. Right? And of course you can use, let me go ahead and turn to technology. Right? And so when I graph this function, come on. Okay, there we go. Right? So we got, if we do my function 2, I'm saying over x minus 1. And there you got it, right? So when we look at this, we can see that it has a horizontal asymptote of 1, and that vertical asymptote where it's ripping itself apart, all right, is at x equals to 1. So it basically has the attributes that I'm asking for: done, finished, new problem. Right? So the next one, vertical asymptotes are occurring at 4 and negative 4. So again, that tells me as far as the denominator is concerned, right, this f of x needs x minus 4 and x plus 4 to happen on the bottom. Right? On the top, it's saying that the horizontal asymptote has to be y equals 2. So in this case, my degree, right, in the numerator has to equal the degree in the denominator. Well, we already know just from the vertical asymptotes I need a degree 2, so this needs at least a degree 2. And the other thing is that the lead coefficient upstairs needs to be 2, and the lead coefficient downstairs needs to be at least 1. So I have 1 down there, right, because if we expand this out, this would be x squared minus 16. So my lead coefficient is 1, so I need a lead coefficient of 2, and then I need a power of 2. So why don't I just simply do 2x squared all over x minus 4 times x plus 4? Or if you want to put it in this form, 2x squared over x squared minus 16. Are there more? Yes. Right? You can just play around with any quadratic that you want as long as it doesn't have a 0 that matches the 4 and negative 4. But there's, infinite number of answers here, but I just found one that seems to fit the information. Again, to be sure, we'll go graph it. So I'll go to my technology. In the upstairs, I put 2x squared. On the downstairs, I have x squared minus 16. And so let me zoom out a little bit. And so we can see that this function has what I want. Right? First of all, it has asymptotes occurring at 4 and negative 4, and it has a horizontal asymptote. It's kind of harder to see that. How about I add that in there? So the horizontal asymptote is y equals 2, right? And there you got it. So that definitely has a horizontal asymptote of y equals 2. So I've got everything. I got all my bases covered, right? It only asked for vertical asymptotes at 4 and negative 4, and it had to have a horizontal asymptote at 2. I've got it. There are many more that do the same thing, but they're also going to add some more stuff to it. I think I found the most bare bones one. So one more, and then I'll do another example where we have more information. But here we have vertical asymptotes at x equals 2, right? And then a hole at x equals -3. So let's stop right there. What does that tell us? Well, this tells us that our function, right, at the bottom has to have x minus 2 and x plus 3 down on the bottom. And because it's a hole, that means x plus 3 also has to be on the top. All right, so that creates a hole situation when I have a 0 upstairs and downstairs, the same factor upstairs and downstairs. But then I'm told that the horizontal asymptote is at y equals 1. So if we left it right here, my degree upstairs is less than my degree downstairs. And that would give us a horizontal asymptote of y equals to 0. So I need the degree to match. So how about we just simply multiply by x? You could multiply just about anything else, but that gets the job done. So upstairs I have x squared plus 3x, and downstairs, if I FOIL that out, I believe I have x squared plus x minus 6. So there is a function that I think does the trick. My lead coefficient divided by lead coefficient gives me a horizontal asymptote of 1. And so again, just to verify that, let me clear this out and clear that out, right? We've got x squared plus 3x, and we're dividing that by x squared plus x minus 6. And there's the graph, right? So we can see the vertical asymptote is occurring at the 2, right, where I want, and at -3, 1, 2, 3, we can see, again, the calculator showing that it exists, but we know that it doesn't. We know there's actually a hole there. We don't see a vertical asymptote. So I've got my whole, my horizontal asymptote. You can see the line y equals 1, right, is basically the job well done. As a matter of fact, I'll just add that. So y equals 1, right? And so I have a function that fits, everything that I want, right? So vertical asymptote where I want it, a hole where I want it, and a horizontal asymptote where I want it. So there you have it. So there's some curve fitting. We're just basically using that analysis in reverse, and there you have it. I'll do one more round of curve fitting, but I'm going to cut away to a new video to do that. See you soon.